Well, hello guys, welcome to another video from Blue Mountain Labs, this one entitled Private and Hybrid Cloud Architectures. My name's Dave Linthicum, CTO and founder of Blue Mountain Labs. And this is going to be a heady one. You got to keep up with this one. The concepts are going to be a bit more technical and a bit more deep than the previous presentation. But hold on, let's go. So some more shameless self-promotion. Blue Mountain Labs, leading the conversation in cloud computing. We're a consultancy doing advisory and development. I have a best-selling book on cloud computing and social convergence. Do the cloud computing blog for InfoWorld. And actually also do a podcast called the Cloud Computing Podcast, which is about to reach episode 200. So make sure you check those out. And also check out Blue Mountain Labs at www.bluemountainlabs.com. So the promise is this thing called the hybrid cloud. And what the hybrid cloud is, via the elevator explanation, is that it takes on-site and hosted systems and public clouds and combines them together to create kind of a uniquely scalable and very flexible architecture. So we're able to use resources that we own and host that exist on-premise. And we're also able to leverage resources from public clouds, such as Amazon and Rackspace. And we can mix and match them to basically create the solution that we need. And the idea being is that some instances we want to use resources that are hosted by us in the private cloud and for security reasons and sometimes control reasons. And sometimes we need to scale up and leverage public clouds. For example, bursts of resources that are required to handle end-of-month processing, end-of-year spikes if you're a retail organization, all those sorts of things. So it's generally speaking a very nice architecture, very flexible architecture, and it's a good idea. So the approaches or patterns that I see in the market include replication and migration, and that's moving code and moving data. We've all done that before as we ported systems and migrated code and information from one platform to another. Interface abstraction, which is a bit more deep. Behavior, data, and processes basically are abstracted away, and we're able to leverage them through some kind of a common abstraction interface. And then also finally, extending virtualized environments are these are kind of the three approaches that I see out there. There's a few more, but these are the basic ones. Current patterns are primitive hybrid architectures, which is migration and interoperability. It seems to be the way people are moving there. So that's taking public cloud, say for example, code and information exists on a public cloud, importing it to a private cloud, or vice versa. And the idea being is that you have to think long and hard about what you're going to move. You have to figure out how to migrate the code and migrate the data, migrate the systems, migrate the software, test it in place, make sure it's working correctly before it's put in production. We've been here before. This is the old port, test, deploy, kind of world we've lived in as we've moved from platform to platform. Interoperability means that using APIs and services, and this is probably one of the most popular movements right now, we're able to basically allow private clouds and public clouds to communicate one to another. They're able to talk to one to another through the APIs and services. So they can integrate systems, they can invoke each other's APIs. They basically become a distributed computing environment where one exists in a public cloud, say Amazon or Rackspace, and the other one exists in a private cloud, say Eucalyptus, and they're able to basically communicate as if they were existing within the same system, but they're distributed, of course, over the open internet. The best solution is cloud abstraction, which is one you don't find too much out there today because it's also the most complex and the technology is emerging. So an abstraction layer in a composite is placed between the user or the consumer of the information, the consumer of the application, or perhaps even another system that's consuming the application, and the back-end resources. And those resources can exist on public, private environments, and you can mix and match them. You could have 5 or 6 private cloud environments and 3 or 4 public cloud environments, perhaps one doing storage, one doing just compute, one perhaps providing information interfaces. And we're able to bring these together by abstracting the APIs into a single composite layer, which allows us to address all of these back-end resources, private and public, through a single kind of common or canonical layer, which allows us to either communicate with another system or communicate with a human being. And this seems to be the way things are going. If you look at the hybrid cloud operating systems that are, kind of emerging today, and we're still in the experimentation phase on that stuff for sure. This seems to be the way to go because it provides you flexibility. You're able to pull clouds off of the back-end systems and put clouds on the back-end systems without typically interrupting or replacing or making huge major changes to the composites that are consuming those cloud services. Pretty cool. So the emerging hybrid cloud architecture patterns, I see four. Static placement, assisted replication, auto migration, and dynamic migration. Static placement, as the name sounds, it's basically putting the services on the systems where they reside, private and public, and they can't move. Typically, they're bound to the platforms. It's uneconomical and too weighty to move them from platform to platform. It's difficult or impossible to port or migrate. It's too expensive, typically uneconomically viable. Little or no use of standards. Typically older platforms mixed with cloud platforms. Little use of abstraction, almost no use of abstraction, and they leverage service APIs as the ability to communicate one to another. This is probably the way most hybrid clouds are being built today. People are, binding applications and binding information to either a private or public cloud environment, and they're communicating through service APIs. Next is assisted replication, code port or interface compatibility. There's some use of standards, typically new platforms that are code service compatible, and there's limited use of abstraction. And that is ultimately we're able to, basically move data and move code and move systems between private and public cloud environments. Basically through an assisted mechanisms to make the port occur. And so this isn't necessarily something that's dynamic in nature. You typically have to shut the system down. The code, the information is migrated from one point to another, brought back up and running, and you're ready to go. Auto migration seems to be where the destination of all this stuff is. Autocode and VM migration and interface compatibility become kind of the core fixture here. There's some use of standards, typically service standards, virtualization code at the data levels, and some use of abstraction. And the service APIs allow us to take all these various components, such as data, such as the services, either existing on public private cloud environments, and migrate them automatically as they need to migrate. So usually this is a bit more primitive than dynamic migration, which we'll talk about next. We're able to shut down the system, make the migration, migrate the information, migrate the code, and then bring the system back up, and everything should work hunky-dory as it exists on the new platform, perhaps moving from public to private, public to public, private to private, however you want to do it. And it provides you with the capabilities and the flexibility to basically move information and move code, between the platforms as you need change over time. Dynamic migration is dynamic, virtual machine migration within a single logical OS. If you look at the hybrid cloud operating systems that we're seeing today, this is the objective. So the ability to provide logical and physical abstraction. There's some use of standards. Hybrid cloud operating systems are basically where we're going here, and they're able to leverage service APIs and an operating system that surrounds the data and surrounds the compute services on the private cloud, and the same on the public cloud, and is able to dynamically move the virtual machines, move the information in between these environments. And this seems to be the destination. So moving into kind of the advanced hybrid cloud world, we're able to put the VMs in their own domain, whether they exist on a private or public cloud environment, migrate them dynamically between private and public clouds, and ultimately provide us with a completely scalable solution, something that we can create with auto migration services. We're able to move from private to public cloud services, perhaps to as the need for compute and storage resources increase, we can set some kind of a policy where it's migrated automatically. So this is very cool if you think about this. The reality, though, is this in a working state, in a production state, doesn't really exist yet. We have some players in there that are starting to stand up hybrid cloud operating systems, but we're still kind of moving in this direction. This is very much at the experimental stage. But this is also nirvana. If you think about it, we basically create our virtual machines, we put it into production, and it's able to move between private and private and public and public and public to private and public to and private to public as needed to support the needs of the business, and perhaps do so automatically. So this is very cool, and this is really the destination of all this stuff, and this is what a lot of the startups and a lot of the bigger guys are working on today. So the other thing to think about is governance. Governance has to be, part of your solution as you move into a hybrid cloud operating system. Services are going to be out there. Policies need to be placed around the services and how they're consumed and how they're managed as you build your systems. And this is just a placeholder here in fact that I'm just trying to remind you that governance and security need to be systemic to your architectures. You need to figure out how you're going to govern these systems in a production mode, how you're going to place policies around the services, how you're going to track things that change over time, making sure that, say a change in a service on Amazon or a change in a service on Rackspace doesn't necessarily blow up your entire system, considering the fact we're getting into very complex distributed kinds of architectures here. So the big message here is we need cloud abstraction, because some kind of a common interface and cloud management that can occur between the private and public cloud environments and perhaps community cloud in some instances. And we're trying to, as an industry, move as quickly as we can in that direction. The difficulty comes in the fact that it's not an easy problem to solve. Virtual machines are immensely huge, and trying to copy them over the open internet dynamically, and the ability to basically move services around and move information around dynamically, or perhaps even automatically, or perhaps even assisted, is going to be something that we're going to need to work on for the next few years. But I think we're going to get there, and I think we're going to have some capabilities that we don't have today that are going to be extremely valuable. So I'm Mr. Methodology. So how do you do this? Well, number one, define your information. Core physical and logical models within your databases, what they are, what they should be, basically coming out of the requirements of the business. Here's a work breakdown for defining information. Create the information model. You have to understand ontologies, understand the data, catalog the data, and then build ultimately an information model. Sorry to sound old school here, but some design and architecture has to go into this in order to get to a successful end state. Next, define your services. What are your core services? And of course, I'm all about the services and the service-oriented architecture, where they are and how they bind back into the information model that we just created. And here's a methodology. Here's a methodology for doing that. Understand the services, list candidate services, and information to services binding, and then build the services model. Service decomposition models, things like that. Things that are relatively well understood in the world of service-oriented architecture. Then define the processes, the core processes that are there within the business, how they bind into the core services, and how those services, like we talked about earlier, bind back into the information model. Then we map to the proper architecture. Static placement, we talked about that, assisted replication, auto migration, and dynamic migration. Which hybrid cloud computing platform, or no hybrid cloud computing platform in some instances, is right for you? Which architecture are you going to leverage? And then, select the technology that's going to work, which is our next slide. So then you select the technology solution: static placement, assisted replication, auto migration, dynamic migration. The first three you can find. The fourth one, as we mentioned earlier, is a bit more complex, and you have to be very careful about some of the newer 1.0 solutions out there to make sure it works in your environment. So, make sure you test, and validate before you go off and spend millions of dollars to march down these directions. Static placement is fairly easy. It's just porting. Assisted replication is basically leveraging porting tools. And then auto migration, the ability to basically migrate things once the system's shut down. So it's something that's not dynamic. You're going to have to do it in a kind of a in the nights and weekends when the systems are not operational and not supporting the business. And dynamic migration again is the end state, and that's the objective we're looking to get to. Ain't there yet, but we're going to be there soon. So don't forget about Blue Mountain Labs. We're a consultancy providing advisory and development services around the emerging world of cloud computing for enterprises and government. And check out the book, check out the blog on InfoWorld, check out the podcast on iTunes. And don't forget to go to www.bluemountainlabs.com for updates here and some more videos. So you guys take care.